Hello everyone. Today we will continue module 8, that is on landslide. So this is the 29th lecture of remote sensing for natural hazard studies. Before we continue, let us quickly have a look whatever we have covered in the last lecture so that you will be comfortable while continuing this particular topic. So when we talk about the landslide, landslides are the downward and outward movements of slope forming material composed of natural rock, soil, artificial fills or combinations of these materials, right. So you have seen these videos where you can easily see the impact of landslide and the scale of landslide. So landslide can be of a smaller scale, it can be of larger scale, right. So when we see the different components of a landslide, so here you can see this particular plane, it is the surface of the rupture, right, and we call it main body, right. Now here you have the crown, this particular line, and then you can see that this particular layer was here basically in the continuation of this, which has shifted because of the landslide, right. So this is known as head and this is the minor scarp. Now this is the ponded water, it can be present, it cannot be, this is just for the example. And here you have the toes, right, these are the toes and this is the surface of the separation. I hope you are following this, all these are highlighted, so it is very easy to understand, but you need to remember all these, that how to characterize a landslide, what are the different features and how we can identify them in the field and how to convey our field investigation information, right. So when we talk about the landslide, basically there are two different factors which are triggering this landslide. So one is shear stress and another one is shear strength. So if there is increase in the shear stress, that will trigger this landslide. If there is a reduce in shear strength of the material, then also landslide will occur, right. So let us see this in the next slide that we have covered yesterday. So when shear strength is high and shear stress is low, then that particular slope is in the stable condition. When shear strength is slightly higher than shear stress, that particular slope is in the metastable condition. When shear strength is low and shear stress is high, then definitely that slope is unstable and we can expect the landslide kind of phenomena, right. This particular slide gives you the information about the causative factor. Here it has been divided into two major categories. The first one is the natural causes and the second one is anthropogenic. But in the field, you will be able to identify whether the natural processes are triggering this landslide or whether the anthropogenic, right. But nowadays human intervention is so high that it is very difficult to segregate or differentiate in the field which one has played more important role in triggering the landslide. But you need to understand what are the different natural causes, what are the different man-made or anthropogenic causes, right. So these natural causes, they are divided into three categories, the geological, right, and then morphological and hydrological. You can see here that geological causes has the weathering, structural related errors, then physical, chemical, biological weathering comes under this. Then in the structure you have stratification and orientation. Then when we talk about this morphological causes, you have topography, surface covers, slope inclinations as well as erosion, deposition and the tectonic activities. You might have heard about earthquakes. So during the earthquakes, what happens? The seismic waves are generated. Those seismic waves produce the vibration at the surface, right? And because of that, upliftment can take place, and that will change the slope of the area. When we talk about erosion, we have toe erosion, gully erosion, subterranean, then deposition on the slope face or on the crest. So all these are playing very critical role in landslide. When we say hydrological, we have rainfall, infiltration, seepage of pore water, then rise in groundwater level. All these will have the impact, and that will change the stability of the slope, and subsequently landslide can occur. When we talk about anthropogenic activity, we have encroachment, deforestation, unscientific cutting of hill slopes, unplanned infrastructure development. All these are from the human interventions, right? So when we talk about the landslide, how we classify them? So there are different ways, different criterias. Based on that, we can classify the landslides. So here you can see the type of movement, kind of material, rate of movement, then geometry of the area of failure and the resulting deposit, age, causes, then degree of disruption of the displaced mass, relation or lack of relation of slide geometry to geologic structure, degree of development, then geographic location of type examples, state of activity. All these are playing critical role. So these are the different bases on which we can classify a landslide, right? So we have also seen different types of mass movement. So here when we have different movement, we have different name for it, right? So starting with rotational landslide, then translational, then block slide, rock fault, topple, debris flow, debris avalanche, earth flow, creep, lateral spread, all are different types of landslide which you may find in the field, right? So here in this figure explains the rotational landslide, translational, block slide, rock fault, topple, debris, then debris avalanche, earth flow, creep, lateral spread, and we have also discussed about the velocity, right? If you remember, based on the velocity we have categorized different types of landslides. Here these videos are meant to understand this debris flow, then you have rotational, translational, creep, rock fall, topple, all are explained here, right? I hope you will be able to perceive that how the material or the mass is moving, and based on the movement we have different name of the landslide. And we also discussed the state of activity, whether it is active, suspended, reactivated, inactive, dormant, abundant, stabilized or relict. So here this is the first phase, and this is where you will hardly notice that there were any landslide incidences, right? Because of the natural processes, the slope is stabilized and there is no relict of landslide on the surface. If you dig here, you will get the information about the past landslides. Now we will talk about the distribution of activity. So here we have advancing, retrogressive, enlarging, diminishing, confined, moving and widening. So this first one is for the advancing. Here you can see the first one, right? For retrogressive, you can refer to this. For enlarging, you have this. For diminishing, here you have, and the fifth one is confined, which is represented here, right? So these are the different types of activities. So starting from advancing to widening, you can have different types of activity of the landslide. So, when we talk about the advancing, the rupture surface is extending in the direction of movement, right. So, if this is the slope, right, and if this material is failing, if this slope is failing, so it is extending in the direction of movement. So, it is extending in this direction, right. Continuous triggers weakening of material at the toe. This is the toe, right. So, at the toe there will be weakening of the material. So, you can see the video here and you can see this is the example of advancing, right. So, here this particular image will help you to understand this phenomena, advancing. So, rupture surface is extending in the direction of movement. So, this is in this direction. Continuous trigger, this is continuously happening, right. So, it is changing. Then weakening of material at the toe here. Now, the next one is retrogressive. So, the rupture surface is extending in the direction opposite to the movement of the displaced material. I have a very nice video to explain this. Loss of support at the toe due to erosion or excavation, weak clay layer triggering progressive failure, right. So, this is the example of your retrogressive, and here you can see how this retrogressive failure is taking place, right. This is the example, the field example. Here this is the zone of previous landslide, right, and this is the zone of second landslide, right. So, this was captured in 2013. This is the source of photograph. When we talk about retrogressive landslide in soft clay, it can be modeled by material point modeling, MPM method, right. So, if you want to know more about MPM method, you can refer to this Wong et al. 2016. A reference is given at the end of this lecture. So, last slide I will give you all the details of the references. So, here the Wong et al. They have modeled the retrogressive landslide in soft clay, and this is from their paper, right. Now comes the enlarging. The rupture surface of the landslide extends in two or more directions, grows over time due to new failures forming along its margins, increasing the area, right. Then weak clay layer triggering progressive failure. So, here you can see how enlarging is happening, right. So, here you can see in enlarging, you just try to look at this particular feature, right. And the next image, here what has happened, this particular feature is missing, right. So, it is because of the enlarging. So, in enlarging what happens? The rupture surface of the landslide extends in two or more direction, that is very clear here, grows over time due to new failure forming along its margin, increasing the area, weak clay layers triggering progressive failure, right. So, this example I hope it is very simple to understand. Then comes the diminishing. Volume of displaced material is decreasing. So, slowly the volume of displaced material because of the landslide, it will be decreasing. Loses energy and volume over time, reducing its impact and movement. So, you can see here with time it is losing its energy, right. And then comes the confined. So, there is a scar, but no rupture surface visible at the foot of the displaced mass. So, here in the confined, you will not be able to see the foot of the landslide, right. So, that is represented here in the confined landslide. I have photographs that will help you to understand this diminishing. So, the volume of the displaced material is decreasing. You can just try to understand this figure, right. And slowly it is losing its energy, right. When we talk about the confined, there is no rupture surface, right, but scarp is present. So, here you can see this particular scarp is present, but there is no toe, right, the rupture surface that is not visible here. Now comes the moving. Displaced material continues to move without any visible change in the rupture surface and the volume of the displaced material. So, without any visible change. So, here you can see this is the case of moving landslide. Then you have widening. The rupture surface is extending into one or both flank of the landslide. Weak side slope collapsing due to continued movement. Erosion at the flank increases instability. So, here you can refer to this widening landslide. So, these were the different types of distribution of activity. Now, we will talk about the style of activity. So, when we talk about styles of activity, the styles of activity describe how different movement contribute to a landslide, and Wern's 1978 he classified the landslide based on whether movement type occurs in sequence, different area or as repeated event, right. So, this is very important. So, this is the styles of activity. So, when we talk about the first case, here we have single landslide. A landslide that occurs as a single movement without further reactivation or disruption, right. So, this is one. Then the displaced material moves as a single block without additional independent movement, right. Then comes the successive landslide. Multiple failure of the same type occur at different times, but do not share a failure surface or displaced material. The failures are independent event occurring in the same area, but without a direct physical connection. For example, irregular successive rotational slip in clay slope, where each failure occurs separately but contributes to overall slope instability. So, when we talk about this successive landslide, it is the multiple failure of the same type of landslide, right. So, when it is happening, we call it successive. So, here is the example of single and successive landslide. So, here you can see there is only one. So, this is single. Here you can see there are two similar landslides happening in the same area, right. So, this is successive. Then comes the multiple landslides. So, here this is the case. A landslide where the same type of movement is repeated over time, sharing a common rupture surface or displaced material. In the previous case, they were not sharing the same rupture surface, right? They were different. Here, sharing a common rupture surface, that is important. If that is the case, we will call it multiple landslide. For example, retrogressive rotational slide where multiple rotational failure occur progressively upslope, each sliding along a deep common rupture surface. So, in such cases we will call it multiple landslides. Then we have the complex landslide, a landslide that involves at least two types of movement occurring subsequently, that is one movement leading to another. Here you can see when we are having this slump, the earth flow is also taking place, right. So, this is the slip surface and here slump and earth flow both are taking place. So, for example, rock topple rock slide, initial toppling of rock masses followed by sliding of part of the topple material. So, here you can see this is the initial slump, right, and here you have the mudslide and here you can call it mud flow. In this case, the right hand image, here you can see the rotational rock slide, this is the earth flow that is taking place together. So, this kind of activity may take place in the nature and we have different names for it, right. Then comes the composite landslide, a landslide where two or more types of movement occur simultaneously in different areas of displaced mass, unlike complex landslide which occurs in sequence. For example, slide toe topples where part of the slope slides while the toe undergoes toppling. So, this is the case of composite. So, here it is important to note two or more types of movement occurring simultaneously, right. So, here this is the example of composite landslide. This particular figure is taken from the AGU website. So, this is the address and here this is showing the multiples of landslide from China and it occurred in 2019 because of the heavy rainfall. So, you can see how many landslides are present in this particular area, right. So, this is one case which I wanted to show because this kind of field traces you can easily see in the surroundings, right. Now, let us see the elements of a composite landslide as observed in the case of Arba's landslide, right. So, here you can see this is the composite landslide elements. And Arba's landslide, if you do not know, it is a composite landslide located in the mountain ridge of the eastern part of the Alps, northwest Slovenia, right. So, here you can see this is the rock face, right, and increase incised gully, active talus. So, here it is important to note that this particular shade you follow, this is the zone of rock fall, right, and here this is the zone of sliding, this is the zone of debris flow. So, here and finally then it is meeting to this particular fluvial system, right, and here you can see the different boundaries, right. So, this is the typical structure of a composite landslide and it is mainly from the Arba's landslide. So, when we talk about the landslide, we also have the environmental and other impacts. So, let us see the environmental impact of landslide. Forests, especially in the tropical regions, are destroyed by landslide. This is one of the major problem, and because of the landslide we are having the deforestation. Debris flow are seen to fill and or erode the stream channel for greater distances. Slumps and earth flow can cause partial to complete blockage of the channel, constrict the channel locally and even cause a shift in the channel configuration, right. So, there may be a modification in the channel pattern because of the blockage, right. So, there may be a new channel formation and that will change the topography of that particular area. Landslide can destroy the fish habitat in short term. The drinking water sources are also affected by the introduction of suspended sediment and organic material. So, if there is a landslide here and people in the downstream, they are mainly using this surface water, right. So, what happened because of the landslide, there will be more suspended sediment and organic material into this surface water and that will affect the health of the people, right. We also have the ecological impact of landslide. Landslides changes the topography and creates erosional and depositional landforms. Landslide create open exposed site with more extreme microclimates than the surrounding terrain. The soil properties and the texture are changed by the exposure of parent material, removal of the organic matter in the topsoil and their deposition elsewhere, right. So, by altering both site and soil, landslides significantly contribute to the evolution of the landscape. So, slowly the things will change here and this particular topography will be filled with vegetation and the new topography will take place, right. So, this is the modification of the topography because of the landslide. So, this is the geomorphological changes. When we talk about the social and economical impacts of landslide, so we have direct losses, damage to infrastructure, so like road, bridges, buildings, agriculture and property, that is very common, and we all know that because of the landslide there may be a closure of roads, there may be bridges problem, there may be a building destruction, right. So, these will be direct impact of landslide. What are the indirect losses? So, we have revenue losses because of the closure of the road, buildings and the agriculture related problem. Then we have revenue losses, industrial, agriculture and tourism sector. If area is very popular for tourism and if there are certain landslide which is frequently occurring, people will avoid to go into those regions. So, the tourism also gets affected because of the landslide. Then property devaluation, so decline in the real estate values, tax revenue losses, reduced property tax collection, then economic cost, debris removal and mitigation expenses, that will be the additional cost to the government, right. Then productivity impact, human and animal losses due to injury, death and trauma. Because of that there will be direct and indirect impacts of landslide on our life, right. When we talk about the landslide risk, impact and economic consequences, rainfall induced landslides are very common and they are responsible for 89.6% of the total landslide fatalities, 14% of the monetary losses and 0.53% of all natural hazard fatalities. That is reported by Hidalgo and Vega in 2021. 3.7 million kilometer square of Earth's landmass is highly susceptible to landslide, affecting 300 million people. That is reported by Mandal et al. 2021. Annual landslide related losses increases from about $50 billion in the 1980s to $200 billion in the last decade. About 914 deaths per year due to rainfall induced landslide. Here you can see this is from this particular report. Why I am showing you all this information? That landslide is a major problem of any country and we have to be very careful and we have to start studying the landslide very systematically. So, there are very good literatures which are available for our references. So, that is why I am referring some of them here to provide you more information about the landslide starting from basic to the advanced level. Now, slowly we will go into the different risk assessment and also the real time early warning system, how we can establish them. So, when we talk about the population affected by landslide in different region between 1903 to 2023, Africa, America, Asia, Europe, Oceania, here you can see the total affected, number of homeless, number of affected, number of injured, total deaths. So the number is huge. That means we have to be very cautious, and we have to start looking at this particular problem, the landslide hazard, as a multidisciplinary approach. So one particular field cannot solve and cannot provide all the information. So we have to join together, and then we have to start looking at the landslide hazard as a multidisciplinary problem. In India, 4.2 lakh kilometer square area is part of 19 states or UTs are vulnerable to varied types of landslide hazard. This is published by Geological Survey of India. This affects parts of 179 districts. 8% of the global landslide fatalities, that is in India, that is by Ram and Gupta 2022. Average annual landslide deaths are 847, and average annual financial losses are around $0.3 billion for India, right. So here you can see some of the examples of landslide, how it is affecting, and these are from India. This is from Dima Hasao, Assam. This is in the northeastern part of India. Then here you have rainfall induced landslide from Munnar, Kerala, and here early warning system has been installed, and I will be showing you some of the examples. Impacts of landslide. So here you have the number of deaths in India. So 1998 to 2018, it is from Martha et al. 2021. So when we say this Malpa landslide, it is one of the major landslide. So here in the x axis you have years, y axis you have deaths per year in 1000, and here in this axis you have cumulative deaths in thousands. So this Malpa, then you have J&K earthquake, then you have Kedarnath disaster. So how the numbers are increasing day by day. So we have to be very careful while analyzing, and when we are talking about the early warning system for landslide hazard. So here you can see this is the map from Geological Survey of India. So it says the susceptibility map, the landslide susceptibility map, and here there are three colors which have been used. The yellow is used for low, green is moderate, and orange or red is for high. So all the pixels which are here in red color, that is showing the high susceptibility zone. The green color says the moderate susceptibility zone, and the yellow is the lowest susceptibility zone. So we can also call it the lowest or maybe the safer compared to the other two categories. This is from one paper which is Sarma et al. 2024. So here you can see the landslide susceptibility map for India, and here it is divided into very high, medium, low, very low, and this red one is the highest class, the highest probability zone, and the blue one is the very low probability zone, right. So with this I will end the part 1 of lecture 29, and I will be continuing this lecture in part 2. Thank you very much.